Consider a book lying on a table. Obviously, the book remains at rest if left alone. Now imagine pushing the book with a horizontal force great enough to overcome the force of friction between the book and the table, setting the book in motion. Because the magnitude of the applied force exceeds the magnitude of the friction force, the book accelerates. When the applied force is withdrawn, the friction soon slows the book to a stop. Now imagine pushing the book across an ice surface. The book again comes to a rest once the force is no longer applied, but not as quickly as before. Finally, if the book is moving on a horizontal frictionless surface, it continues to move in a straight line with velocity constant until it hits a wall or some other obstruction. The net force on a object is defined as the vector sum of all the external forces exerted on the object. External forces come from the object's environment. If an object's velocity isn't changing in either magnitude or direction, then its acceleration and the net force acting on it must both be zero. Internal forces originate within the object itself and can't change the object's velocity, they are compensated. A consequence of the first law, as we will see, is the feasibility of space travel. After just a few moments of powerful thrust, the spacecraft crossed for months of years, and its velocity only slows changing with time until the relatively faint influence of the distant sun and planets. Let's go to the first law of Newton, which was originally formulated by Galileo Galilei. Inertia is the measure of an object to continue its motion in the absence of a force, and mass is the measure of the object's resistance to change in its motion. Well, the first law of Newton says that in the absence of external forces, an object will remain with uniform motion, which means being at rest or being with a constant velocity moving in a straight path. If we have two objects with different masses, let's say a car and a truck, and both of them are in the absence of external forces that will continue with the same velocity, let's assume it's the same velocity. But because the truck has larger mass than the car, the truck has larger inertia and larger resistance to change its motion. So if we want to stop both vehicles, we will have to apply a larger force onto the truck because of its larger inertia, larger resistance to change its motion because of its larger mass. And that takes us to Newton's second law. So Newton's second law tells us that the change in the motion, which is the acceleration, is proportional to the external force. Or, in different words, we can say that an external force, a net external force acting on an object, is going to change the motion of that object, so that object is going to feel an acceleration. And the constant of proportionality between the force and the acceleration is going to be the mass, which is the inertia that that object has. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass. And in Newton's second law, we can write it as the sum of all the external forces, which is the net force, which is equal to mass times acceleration. So if we want to know the acceleration, it's just inversely to the mass and directly proportional to the net force. So that's the net force divided by the mass. After this equation, we know that an object with twice the mass of matter accelerates only half as much in response to exactly the same external force. And the more matter an object has, the more it resists accelerating in response to the same external force. Let's go now to Newton's third law. It's commonly known as the action-reaction law for forces, and it says that if two bodies exert on each other forces, these forces are equal in magnitude and opposite in direction. So if I have an object A and an object B, that object A is making a force on object B is going to be exactly doing the same exact force on object A, but with opposite direction. For example, think about the Earth and the Moon, that's gravitational attraction. The Earth is attracting the Moon with the same force as the Moon is attracting the Earth, but in opposite directions. Or if there's a collision between two balls, then the ball on the right is making exactly the same force on the ball on the left, but in opposite direction. That's what we usually call the law of action and reaction. For example, when you are walking, what you're doing with your shoes is you are applying a force on the Earth backwards, so the Earth is doing a force on you forward, so that's the way you move, you walk. How airplanes work is that they push the air backwards so that the air is pushing them forward so they can fly forward. And that's what spaceships also do. They just eject some gas and high pressure in one direction so that high pressure gas is pushing the spaceship in the other direction. Always using Newton's third law, action, reaction.